Welcome, ladies and gentlemen, to this video lecture. So in our previous lecture we introduced the definition of a limit. Here it is. So what we will do now is we will have a little preamble on logic. Okay, there are some words in the definition of a limit which have very specific meanings in mathematics. So let's point those out. So I will now point out let's say some of the most basic concepts in logic that we will need. So these are words that you should always watch out for. So the first one is the phrase for every. And we can already see that that occurs in our definition of a limit. So this for every phrase, that has a specific name. It is called the universal quantifier. Universal quantifier. So for every is called a universal quantifier. It is called a quantifier because it quantifies one variable. So here in the definition of the limit, it quantifies this epsilon. So, and it is a universal quantifier because it makes a statement that should be true for every epsilon. So it what follows should be universally true. And then the next phrase is there exists. And this is what is called an existential quantifier. Existential quantifier. And we also see that that occurs in our definition of the limit. There exists a delta. So the existential quantifier quantifies a variable, and it says that there should exist at least one of these things. So there should exist at least one delta so that the rest of the statement is true. So that is an existential quantifier. Then the next thing that you should keep an eye out for is phrases of the following ilk. If blank, comma, then blank. This is what is called an implication. And we also see here that an implication occurs in our definition of the limit. Next, what sometimes also occurs in logic is this word not. So that is called a negation. And then also we have the words and or. And these are what are called logical connectives. Why are they called logical connectives? Because you can connect different statements together. So if you have two true statements, A and B, and you say A and B, if A is true and B is true, A and B is also true. If one of them is false, then of course the connected statement A and B is also false. Okay. So these phrases you should always keep an eye out for. Okay. Next thing that we will discuss is what is called logical statements. Logical statements. So what is a logical statement? It is a statement that is unambiguously true or is unambiguously false. Or is unambiguously false. Okay, so what you can think of as logical statements, you can make the statement that 3 is equal to 2. This is unambiguously false. You can make the statement 2 is equal to 2. This is unambiguously true. You can make the statement 0 times x is equal to 0 for all x in the real numbers. This is unambiguously true. So here we have some examples of logical statements. And then we can also have what are called predicates. Predicates. So what is a predicate? So a predicate is a function that evaluates to a logical statement. Depending on the input. So, for example, we can have a predicate, let's say M, depending on some variable x, some input variable x. And let's say we define this predicate to say that x is married. Now, depending on what the value of the variable x is, this predicate then evaluates to a logical statement, meaning a statement that is unambiguously true or unambiguously false. So, for example, my friend John, he is married to my other friend Alex. So, if I put in John's name here, John, this then evaluates to the statement John is married. And that is unambiguously true because John is married to Alex. And on the other hand, my other friend Martin is not married. So this is unambiguously false. So Martin is married. This is false because my friend Martin is not married. John is married, so that is true. And now we see here the predicate can evaluate to different logical statements. And it is either true or false. So any person you can put in any person's name here into the input of your predicate, and it will evaluate to a logical statement, a statement that is unambiguously true or unambiguously false. Okay, so those are examples of predicates. And then what we will get to is what is called a quantified logical statement. So a quantified logical statement. So what is a quantified logical statement? That is a logical statement meaning it is unambiguously true or unambiguously false, in which all variables are quantified. So all variables that occur are quantified. So, or let's say all variables in predicates are quantified. So for example, if we continue with our predicate up here, X is married. X is married is not a logical statement because it is we cannot say whether X is married is a true statement or a false statement. It is not unambiguously true or not unambiguously false because it depends on what X is. Okay, so this is not a logical statement. So MX is not a logical statement because it depends on what the variable is. So this variable is what is called free. This variable can be anything, and depending on what it is, it can make the statement MX true or false. So this variable is free. It is unquantified. We can make this this predicate M of X into a logical statement by quantifying this variable X. So what do we mean by quantifying a variable? It means we apply one of the quantifiers to it. So either the universal quantifier or the existential quantifier. We can do either one of them. So we can say something like for every X, and usually what we say is X lives in some set A. Let's say some set. Let's write it this way. For every X, so let's let A be a set, and then we can make the statement for every X in this A, M of X. And now this is a logical statement. So it says for every X in A, M of X is true. So now depending on what this set A is, this becomes a logical statement. So for example, if we say A is the set of all men on earth. let A be the set of all men on earth. And let's consider the following statement. So for every x in A, m of x. Is this now a logical statement? Yes, it is a logical statement because it is either unambiguously true or unambiguously false. So let's think about it. This statement says, for every man on earth, that man is married. So this is of course false, because my friend Martin is not married. So this is false. We could also use the existential quantifier. So there exists x in A, so that m of x. So what does this say? This says that there exists a man which is married. And that is true. Of course, my friend John, he is married. So this is true. So now you see here how we can make out of a predicate let's say a function that evaluates to a logical statement depending on the input. We can make that predicate into a logical statement by quantifying the variable that we are working with. So in this case we have for every man, so here this first statement, for every man, that man is married. That is false because there are some men who are not married. And our second statement here, there exists a man who is married. And that is true because some men are married. My friend John is one of them. Okay. So this is sometimes a little bit difficult to wrap your head around how we can make out of predicates logical statements by quantifying the variables. But this is not the first time, or no, this is not the last time that you will see this. Okay, so in this lecture, what did we introduce? We introduced these phrases that you should keep an eye out for every, or a universal quantifier. There exists, or an existential quantifier. If, then, which is an implication. Not, which is negation. And logical connectives, and or. And then we also introduced logical statements. So what is a logical statement? It is a statement that is either unambiguously true or unambiguously false. And we introduced a predicate, which is, or predicates. Predicates are not logical statements because without knowing the value of the variables on which they depend, we cannot say whether they are true or false. So they are not logical statements. We cannot say whether the phrase X is married, whether that is true or false, if we do not know the value of the variable X. But if we substitute in certain values for the variable X, it evaluates to a logical statement. And then finally, we introduced quantified logical statements. So what is a quantified logical statement? It is a logical statement that is built up out of a predicate in which every variable of the predicate is quantified by either a universal or a existential quantifier. Okay, and let us end this video here. I will see you in the next one.